everyone. Now the next topic with Thomas Graf. We're collaborating on the open source topic since many years. Great to have you here today talking about SBOMs.
Yeah. Thank you very much, Roger. Thank you very much for having me. Well, before we start who I am, my name is Thomas Graf and I'm doing license compliance stuff here at Siemens. So I'm trying not to talk too much about license compliance, otherwise you may fall asleep, but we focus on SBOMs. Maybe some questions to you. Who knows what an SBOM is? Just raise your hands. Okay. And are there any people who know what the Siemens standard BOM is? At least a few of you. Perfect. So what's an SBOM? SBOM, a software bills of material. Actually, this should be a list of the components that are used by a specific system. So it should be machine pressable, machine readable. It should contain as much information as possible. Should contain maybe hierarchical information, so which component uses which other component. The components should be uniquely identified. And it should contain open source components, but as well commercial components, because this is at least the use case for us at Siemens. And it's important, it should be automatically generated. So if you remember the previous talk where in the great presentation was shown how to get information about the contents of a container of a specific system, so they have the list of all the Linux packages, Yocto packages, whatever. This should be available maybe as a software bill of material. But is just having an SBOM, is this what we need? So you may all know these nutrition facts, and it's a good analogy what an SBOM would look like. So for a nutrition info, you would like what's inside the food that you intend to eat. But if you look at this, you have fat, you have cholesterol, sodium, and all this stuff. But let's say if you're a vegetarian, do you know whether there's meat inside? You don't. What about if you are allergic against nuts or something like this? Do you have this information here? You don't. And with SBOMs, it's a little bit similar. So you really need to define what kind of contents do you expect for a software bill of material. There are two big standards, open source standards at the moment, SPDX and CycloneDX. And the SPDX people, they had a look at the different kind of SBOMs. And they look at it at the point of time where you created or how you created. So you can have a look at the source files. Just looking at the source files and then determine, okay, what kind of components do we use? One version of an SBOM. You could also say, okay, we compile the source code because then for sure we know which files have actually been used and which have not been used. Second type of SBOM. Or you look at all the artifacts that have been created and you try to find out from the artifacts what kind of components have been used. This is the most common use case, and this is also what it's called the third-party BOM. But you can go further. You look at the deployment. So which of these artifacts are really deployed on a certain system, or even further, which of the artifacts are being used at runtime? So all of these are valid SBOMs. But which one do we want to have, or do you want to have for a certain use case? And we heard we heard Yocto before. And at FOSDEM, there was a great presentation from Yocto people, and they said, okay, we can build a very comprehensive SBOM. Unfortunately, it's nearly 160 megabyte. So do you want to parse such an SBOM, or do we want to ship such an SBOM to customers? Might be tricky. So that's too fast. What kind of use cases do we have at Siemens? So the one where I'm coming from is software license compliance. So we want to know which third-party components are being used, and we want to have a lot of information about these third-party components. Where do they come from? Where do we find the source code? This is for us especially important. And for us, this would be something that we use internally. The second use case would be security vulnerabilities, so similar to the stuff we've seen before. Here we're maybe not that much interested in the source code or where it comes from, but we want to know, are there any known vulnerabilities? Do we can get a list of CPEs as SBOM? And the third use case, which is now upcoming, is the regulatory use case. You may have heard about the executive order of President Biden or about the EU Cyber Resilience Act. This may force us, or may force all companies that try to do business in the USA or in the European Union to ship SBOMs to customers. But they probably want to have not that much information inside. So a lot of different use cases. Another point of view on all this stuff would be interoperability. So where do we use SBOMs, or where do we exchange information? We have different software ecosystems. We have different vendors. So the question would be, will we really get SBOMs from all our vendors? Might be tricky. What about container images? Is there one SBOM for a container image, or do I have one SBOM for Debian, one SBOM for JavaScript, one SBOM for Python backend, whatever? What about all our partners? What kind of information do we exchange here? What about all the different Siemens organizations? Are we able to exchange all the information that we need? And a lot of more use cases. And that's just the first. The other thing is, I guess most of you are developers. So I'm talking to development teams all over the world, and I want them to create SBOMs. I want them to create accurate SBOMs and complete SBOMs. But when I talk to the teams, I see every team is a little bit different. The product is a little bit different. The software ecosystem is different. So there is not a single silver bullet. There is no solution that fits all. This is what we've seen. So the idea is that we have a set of tools that we can provide to create SBOMs. But even more, even if we have tools that are potentially already available, maybe as open source, we think we need more. We need to have libraries. We need to enable you to create an SBOM in your continuous integration the way you would like to do it. So this is what we are looking for. And about 1 year ago, by chance, a group of people within Siemens set up, this is really what we are looking for. It would really be great if we have such an SBOM format and if we would have such a tooling. And it's available. So we don't have only a nice URL like SBOM Siemens. Oh no, we have a website, we have the specification of the Siemens standard BOM format, we have a list of tools, we have resources, we have frequently asked questions. So here you can find a lot of information. Sorry for all the non-Siemens guys. At the moment, this is Siemens internally. But well, what is this Siemens standard BOM about? Actually, it's for sure a standardized machine-readable format, and it's based on OWASP Cyclone DX. So all of you who have to do with something with security vulnerabilities, you may know this. OWASP for sure, but also Cyclone DX. So we decided for an open source format. And the format is programming language agnostic, because at the end it's just a JSON file. It's independent of the ecosystem, so you can run it, you can use it for every ecosystem. All of this is no problem. And we also wanted to be independent of our backend system, so of the consumers of the SBOM. In Siemens, we have different kind of consumers, but we try to have a common format in Siemens for all these backends. So I said it's Cyclone DX, but why do we need something special? Why can't we use just plain Cyclone DX? And this is a little bit based on the fact that we need to understand exactly what's inside the SBOM. But you heard in the beginning, not every SBOM is like another SBOM, so we needed some more definitions, some more conventions, how to make it more precise what kind of information should be inside the Siemens standard BOM. So it's still Cyclone DX, but we said, for example, we defined we need to have a flat list of components, at least in the main part of the Cyclone DX SBOM. You can define hierarchical things or tree structure somewhere else in the format, but for the main list of components, we wanted to have a flat list. And then we needed some additional properties, so just properties for us, and they should be clearly identifiable. So what Cyclone DX offers is a namespace. So you just provide the Cyclone DX people with the property taxonomy, and then you can get your own namespace. And it's really nice that we have this Siemens colon, and then we can say, okay, for example, Siemens file name is the file name that we use. Siemens primary language is what we assume is the main language for a certain software component. And maybe the most important thing for us was, how can we extract the information about source code? So here, for example, we have the URL, which says, okay, this is a local file, but we also have the upstream URL. This is what we need to find the source code, because we need the source code for scanning. And the last thing is that if you pack all these things together, the binaries, the sources, and the SBOM JSON file, this is what we call a standard BOM package. And this is something that you should be able to forward to our backend systems for further processing. Now, it's the Siemens open source conference. Well, so where's this open source part? Actually, we decided we want to have an open source format. So in the beginning, we had a lot of customized formats, proprietary formats. We decided for Cyclone DX. And we heavily used all the Cyclone DX tools, all the Cyclone DX libraries for the different ecosystems. And we also tell the Siemens developers, look, maybe we have our own scanner to do some work, but if we don't have our own scanner for your software ecosystem, just look out what's available on Cyclone DX, what kind of open source tools exist to create such an SBOM. And we try to bring all our changes upstream. This was important for us because we want to interact, we want to discuss things with the Cyclone DX people, for example, and we did contributions to Cyclone DX, to Package URL, to CIF, to SW360, and to some more projects. So we think, yeah, we may have our own use case, but we would like to discuss it with the open source community to bring all the team, all the projects, all the libraries to a better state. And also, we encourage the Siemens developers to do the same. So if there's a problem with the Cyclone DX tool to determine Go dependencies or whatever, don't ask me. I'm not an expert for Go, and I'm no contributor to the Go project of Cyclone DX. Go upstream, talk to them. Maybe just do not open an issue, open a pull request. Most probably they will accept it. And we decided we need to talk about these things. So you see it here, the FOSDEM shirt. A couple of us, so we joined FOSDEM to have a presentation about SBOMs and to discuss with other companies, but also with the open source communities. For example, the ones from Yocto. What kind of information do we need? And what is the best way to get this information? And last but not least, we want to bring our own tools open source. We want to bring them to the community. And when I created the first version of the slides, we wanted to do it, but now it has been done. So at least one of our tools has been open sourced 1.5 weeks ago. So we do this. We try not to keep a secret how we do all these things Siemens internally. Now, so much talking about theory and processes and all this. What does it look like at the end? So it's a JSON file. I know it's small, but it's not too complicated. You have a type library, author, or maybe a group, a name, a version, a package URL for unambiguous identification, If we find information about licenses, you can put it here. You have the information about the source code. You have information maybe about the version control system, and maybe some Siemens properties, or even information that we found during our scan. So if you use our tools, they probably would already find some third-party notices or some copyright strings. So it's not too complicated, and it's still readable for a human being. So it's not kind of binary format or not. Well, there is an XML version of CycloneDX, but we decided we want to go for the JSON version. That's easier to understand. Now, what do we want to do with this? So we have developers and they check in code, hopefully to code.siemens.com. You see all the t-shirts here. And there should be a CI pipeline, and in the CI pipeline, you do a dependency scan. So you can use our scanners, or you can use probably one from CycloneDX or from SIFT or whatever. Maybe, well, then you have a first version of the BOM. But maybe some information is missing, or you want to download source code, or you have a container image and you want to merge different SBOMs that you already have. So we have tooling for this. And hopefully at the end, you have a standard BOM or a standard BOM package with all the information that we need for further processing. And this can be forwarded to our software license compliance backends. So we have at least 2 of them. And what we then do, we scan the source code, we try to determine the licenses, the copyrights, and some more information. And then this information is provided back to the development team. Why am I showing this? Because for us, the SBOM is an input. Here it is an input, so we need to have as much information about the components that you use or that your system uses as possible. And we need to clearly understand what's inside the SBOM. Since there was this executive order from President Biden, hundreds of teams all around the world trying to create SBOMs, but only very few of them try to understand the SBOMs. They just create them, and there have been a lot of discussions at FOSDEM, for example, about the different SBOM formats or what the right contents of an SBOM is. And one team showed an analysis that showed, okay, we have one project and we have 3 different tools to create SBOMs, and actually the first 2 tools have no component in common. So 80 components here with unique identifiers and 80 components here, but unfortunately no match. What kind of advantage do we have from such kind of SBOM? So this is why we decided, okay, we need to have a little bit Siemens flavor, a little bit more conventions or definitions that we can clearly understand what comes into our processes. So this was about input, and here we talk about output. So EU Cyber Resilience Act, President's executive order, they want to strengthen the companies. They want to strengthen the users, because all these users of software should understand what's inside the software. So from the regulatory point of view, they want us to publish SBOMs. What should be the contents of the SBOM? It's still in discussion, but it needs to be something like name, version, a unique identifier, but what is unique? Maybe package URL. And we discussed our approach with our cybersecurity people, and they said, well, if you already have tooling, and if you base all your things on an open source standard and on a standard that is in favor of all these things here, then we should use this standard too. But we don't want to provide our customers with all the information. So for example, not with a 160 megabyte of a Yocto build. We don't need to tell our customers which files we have used. We don't need to tell the customers necessarily all our license findings. This is a separate part, the boring part with license compliance. But we decided we need to have kind of profiles. So we have one profile for clearing. This should be a software bill of material that contains as much information as possible. And we have a profile external, and this is then limited to the information that we are obliged to forward to our customers. So maybe this is the roadmap that we had and that we will have, or where we will continue. So in the early times, everybody created his or her own SBOM, proprietary. Every team had a different one. Every Siemens organization had a different one. And over the time, the open source standards evolved, and we always had a look at them, at Cyclone DX and SPDX. And as soon as we found out, okay, we can use this stuff, then we came up with Siemens standard BOM version 2. And this is now based on Cyclone DX. And, the cybersecurity people decided to use our SBOM, and now we are probably somewhere here. But there's still some way to go. We should have more tooling, we should have more libraries, and at least I hope for that somewhere there might be a complete state, complete saying we have tools for everything. And all of you are using these tools. Might be hard to achieve, but at least it's a goal. Huh? You know, the management goals well, the other part is that we want to open source more of our stuff. It's not always easy because some of our ideas, let's say, collide a little bit with the ideas of the open source world. Most of these open source standards, so like Cyclone DX, they are based on security vulnerabilities, and we're still trying to convince them that source code is important information, but still most of the scanners that are available do not provide this. So the basic Cyclone DX scanners do not provide you with information. What is the website? What might be the GitHub address? Also, if you look at tools like Sift, I heard for Debian, for example, yes, they provide information about source code, but for Python or for .NET or for JavaScript, they don't. So maybe we can do here some more work from our point of view and to bring more of our tools open source. So I'm standing here doing the presentation, but you can assume a single person cannot do this. So it is a group of people, and at least for Siemens, it's important. We are all from different organizations. So we're from smart infrastructure, digital industries, IT, from corporate technology. So all of us come from a different part of Siemens. But there's also the open source approach. We work together in a very collaborative way. We do it on code.siemens.com. It's all inner source. Everybody can have a look at the information. Everybody can open up an issue and discuss with us what is maybe needed, what should be improved. So all of this is at the end done in an open source way. And I guess we have enough time for questions, but so there are more people. Florian is sitting down here. Gernot is sitting over there. So I'm not the only one that you could ask. Because that's it. That's what I wanted to tell you about SBOMs and the Siemens standard BOM. Thank you.
Hi, thanks for the presentation. It was really interesting. I've got a question about how do we deliver software? I think we are starting to move towards delivering the software as a service. How important is SBOM if we provide it as a service? And how do we include everything? I mean, not the application, I mean also the infrastructure, Kubernetes, etc.
Well, let's say, so the question is, in the modern work that we do, software as a service, do we need their SBOMs, or how do we include all the information? So I'm not an expert for Kubernetes, but when we look at license compliance, in a big company like Siemens, you also need to ensure that all the backend systems that we use, that we are at least allowed to use them. So if we do scans for licenses, and if we come across a keyword like not for commercial use, it would be a problem. Not that it happens very often, but it's something that we scan for. So we also scan the containers that we use in our backend systems. And we want to have the complete overview of what we are using at a certain point of time for all our system products or whatever. And for sure this applies to the products that we ship, but also to our cloud offerings. So if you have a look at the front end of a cloud application, you have JavaScript, and you may know technically the UI is rendered at the customer's browser. So technically you transfer JavaScript code to the customer's machine. And from the legal point of view or the license point of view, then you distribute code. And the open source licenses just talk about the distribution of code or distribution of information. They do not care how you distribute it or why you distribute it. They do not care whether you use the code. All of this is irrelevant for the open source licenses. But we discuss it with our legal team. So when we transfer somehow source code, JavaScript code, binary code to someone else, then we should know whether the license allows us to do this. So we do license and analysis for all our front-end stuff too.
Okay, thanks.
First. I'm not sure which one to pick. Does how do you say that?
KPCLI?
KPCLI support the Catkin package manager? Catkin? You also don't know it, okay.
No, I don't know the package imager, but you know it's open source, so I'm happy to see some contributions. I guess you expected the answer, no?
What I've seen on these tools mostly are based on what package managers report or so. Do you have also tooling to detect how software comes into a device? So if I say, I take a Debian image, Alpine image, container image, and then I take a binary from a Debian image, put it into that image, then the typical scanning tools wouldn't detect that.
Yeah.
So, and that's one point. And do you have somehow supply chain tooling to detect? So if something like this happened, that you can say, okay, this binary was introduced by a developer. So signing mechanisms in Toto is one tool that has been used for this. So do we have something like this? Or some concepts?
What we want to have is tools that allow developers to determine the software bill of material. I said there's no silver bullet, and for sure the whole process does not relieve the development teams of using their mind to think about what kind of software do we produce and what is part of our software. So if you decide to create a Docker file that uses curl to pull a binary from somewhere else, most of the scanners that we know, also the commercial ones, will not detect this. But I trust that our development teams know what they are doing. So all the tools are only a help. You still need your head, not only your fingers.
Thank you very, very much, Thomas, for the presentation.